Hey everyone, in this video let's talk about the directory structure for building APIs. Now we're going to make a ton of assumptions obviously, so we can learn a few things. My hope is you do learn a few things as part of this process. Uh, Depending on this tag, that structure is going to obviously be slightly different, but what I'm going to talk about here is reasonably generic. Whether you're building Node APIs or Ruby APIs or Java APIs, I'm sure you can, the directory structures, the namings and the subdirectories are going to change depending on what you're building. Keeping that aside for a second, I want to just talk about a high level structure that will work for a number of cases. So I generally, I do full stack development, but I do a lot of work on the server side, and I've done this for a while, and I've seen that this structure holds me in reasonably good stead. And there are some stacks like Rails for Ruby on Rails, for instance, that actually mandate to a large extent that you follow a certain directory structure. So we are not going to, in those cases, this may not necessarily apply. But if you took a lot of the other frameworks, a lot of them give you the flexibility, and I actually tend to choose those that do give me that flexibility. So just to write something here so it's not a blank screen, I mentioned Ruby on Rails, which essentially gives you, it's more convention than configuration based, so it gives you a structure. You can deviate from it, but it's just going to make your life a little more difficult. And then I mentioned Node.js. I mentioned other Ruby frameworks. You could take Sinatra or Padrino or one of those things, etc. I also mentioned Java / Spring applications. Again, these are broadly different stacks, so things are going to change. But let's talk about the parts that don't necessarily have to change, and you can start with this and make the adjustments as needed. So without further ado, let me start naming some of these directories. So let's say I'm going to call one of them config, and let's see what kind of stuff can go into these directories. So this could hopefully serve as some guidance if you're starting a brand new application, right? Or a server-side API app, which essentially caters to either a web client or a mobile web client like HTML5 apps or a native mobile. This would be pretty generic in a sense. So config. And then I'm going to create one called lib, and we'll see what can go under that. I'm going to create one called test. I'm going to create another directory called data. Let's just go with that, and I'll make the adjustments as we speak. And again, I don't necessarily come prepared when I do these videos. It's just whatever I remember. So if I make a mistake, I'll just go back and fix it. So let's start with the lib directory, because that's where most of your stuff is going to live. Let's start with the basics, right? So I'm going to create one directory called models. I'm going to create another one called services. I'm going to create a third one called services. I'm going to create one called security. Okay, I'm going to create a fourth one called routes. Then I'm going to create a fifth one called helpers, and then maybe another one called tasks, right? And we'll see what these can include. I think that's a decent first set of subdirectories to go with, and let's talk about what kind of stuff can live here in the directories we've created so far. So config is everything that's configuration related, right? So this can have multiple subdirectories. Say you store your config in, say, YAML files, you might create a directory called YAML, and this file can store all of your YAMLs. Like say you have one called messages.yaml, and if you are supporting multiple languages like I18N, then you could have further directories by the locales. So you could call it en messages_en.yaml or messages_fr.yaml for French, etc., right? But let's say you have one that has all your apps messages, your system messages that serve the end user for the most part, right? And let's say you have another YAML called error.yaml. This could essentially have a mapping of your error codes and the error messages that you send back to your clients. And there could be a key.yaml that stores your encryption and other related keys. And now some of the stuff you wouldn't check into GitHub key, for instance. but the key YAML, you could split it into multiple files. Some of it can actually be committed to GitHub, and the others could be environment files which you just store on your deployment environment, whether it's Heroku or AWS or whatever it is that you use for deployments. Now, this list is generally a long list, and then you'll have one called security.yaml that stores all the security related messages and stuff. So you get the idea, right? There's a bunch of YAML files. And then on top of the key.yaml, I sometimes use a keys directory, which stores all my encryption keys. Hopefully you can read some part of the handwriting. You'll have your encryption keys, which could be environment specific. And even if you don't check these into the GitHub repository, you might have them locally, so you know that your app depends on these, and you would just create them on your deployment environments, so to speak. So those are two directories, but you can imagine a lot of other kinds of configuration stuff that essentially would go into, let me just pick a different color, that would go into the config directory. Next, let's go to the easier ones, test and data. Maybe we can come back to lib. Data is, I typically store, let's say you are stubbing out some calls to your API app would integrate with a lot of other third-party services. Now, if you want to stub your APIs, so you don't have to make these outgoing calls when you're building them, because you don't want to have a number of external dependencies, then you can store your JSON responses that you expect from those third-party services here. So it's different from test because this essentially stores data, raw data that your app consumes, needs, or produces. So just a convenient place to stick all of that stuff in. Test, if you have, not if, but depending on how good your test coverage is, you want to store all your tests here, be it functional or unit tests. You can further break this down into unit/functional. And again, once again, depending on the language and the stack, the semantics do change. So what's functional/unit in one framework is unfortunately not the same in the other. But the essence is unit tests, whether it's TDD or behavior driven, they test at a unit level. The functional test your services in entirety. Sometimes I write curl scripts, so I create a curl directory here, and then I store my curl scripts because as a small shop, we don't necessarily have the bandwidth to have the kind of coverage we would like. So we use curl scripts to do a lot of the testing. They are functional tests, but slightly different because they're cross-cutting. Now we'll go to lib, which essentially stores most of what we need from an app standpoint. And here I created, we created a bunch of these directories. There's going to be more to this list, and these would change depending on the stack that you're on and depending on your client or your business needs. But this is not a terrible initial list to go with, right? So models, what do models store? Anything that interacts with your database, interacts with your persistence layer. I call it persistence layer to make it a little more generic, but 9 or 10 times or 8 or 10 times it's going to be your DB, whether it's NoSQL or RDBMS, it doesn't matter. This is where your models are going to be. Anything that interacts and has dependencies on your databases, you want to store under models. And again, I've seen people have a flat list of models. You could have like 40, 50, even hundreds of them. That's difficult. I love namespacing, so I generally further break that down. So in our case, for instance, as far as Snowpal pitch is concerned, the kind of directories we would have would be keys, we would have pods, we would have blocks, we would have tasks, and we got a ton of other stuff. So you hopefully get the idea, right? So that's this would store all of the models. Now under keys, you're going to have all a variety of files because your keys are dependent on other keys. They inherit, they use a lot of design patterns. So anyways, all long story short, all your models live in the models directory, right? Now let me go create one more. I'm just going to call it let me create one more file here. I have to close this, add one more. Okay, let's pick up from where we left off on that page, right? So I think it was the next one on the list was services. So under services, essentially, actually, before we go to services, maybe we should talk about routes. The terminology itself could be different again between stacks, but essentially this is what your client's going to call. Whether you're building REST APIs or you're building, it doesn't matter whether you're building REST APIs or whether you're building graph APIs. You would, in the case of graph, you would call them resolvers. These terminologies always change, but that's the essence. Resolvers are related, not exactly the same, but I don't want to go into a particular stack because then it kind of skews the discussion in my mind. But I just want to call out for some examples. Whether you're building REST APIs or graph APIs or whatever it is that you're building, your routes is going to contain all of those calls. So in our case, again, coming back to just taking our example, slash keys, if let's say we have REST APIs, our slash keys would give us a list of keys, and then a keys.:id would give us a particular key. And then if you want something inside of a key, which is blocks, we would do key/blocks, and then inside of a block we would have :id. I'm just taking a very basic RESTful resource. Graph works completely differently and it's a whole lot more convenient. So with graph, you don't have to, if you're sending more or fewer attributes, you don't have to make server-side changes because you could build them into your implementation. So the client can ask you for the attributes they want and ignore the ones they don't want. So it's very cool, right? I highly recommend using it if you're starting out building a new API layer. I just gave you an example of one of the routes. So this routes file is going to have just about every possible API call that your client is going to make, right? So again, there would be variations possibly between your native apps and your web apps. So you could prefix them with API, or you could prefix them with versions, because within API you're going to have version 1, version 2, version 3, or if you have a single version that's going to further be categorized down into APIs and webs and whatnot, you could start with /v1 and then have API and web, and you could have a version number for the API tagged along to these calls as well for backwards compatibility. So again, this is depending on your requirements and how big or small your product is, etc. This is going to grow, but the gist of it is you're going to have all your routes defined in the routes directory. Now I just want to make sure I'm still recording here. I am. Okay, that's cool. So let's go to services. What do we have in services? Your client, I have not used the word model view controller, MVC or MVVM, etc., etc. Just trying to keep this a little more generic than that. So services, somebody's going to make a call to APIs. So the call, I'll draw a better diagram, or as good as I can given my handwriting, in the next video. So your call comes to a route, sort of a high level walk through the workflow, the steps necessarily. So your call comes to a route, and now you you don't want to make API calls. I've seen code like this where there are calls made directly to the DB layer. That's, I think, a terrible idea, right? Because there's no separation of concern. You want to make sure you want to keep each layer as separate as possible from the other layers. Now, microservices is another word that comes to my mind in the context of this discussion, but I will not go into it. But just let's keep this as simple as I am able to. Try not to make DB calls or dependencies between your routes and the DB layer. That's going to be a bad design. You're going to regret it for sure. So you want to make calls from your routes to your services. So in our case, we would have a key service, a block service, a pod service, and a plethora of these services, right? And now you're going to initialize these services. I mentioned just directory structure, but realize I'm talking about design patterns here, which may or may not be a great idea, just trying to cover too many things in one video. But sometimes I just find it difficult to keep it small and focused. I have to improve, and I hope I will one day. But for now, you're going to have a bunch of these services. Depending on the route, it's going to call each one or more services from within the routes. And let's say we are making a simple call to getting a list, fetch a list of keys. I'm going to have a route, and then that route is going to call out to a key service, and it's going to initialize the service with all the necessary dependencies like the security, the user context. We want to know a few things about the user and about the request itself, right? So the user is a param or an instance of this key service, and then the request params. And there are more things, but these would essentially the service would be created with these attributes, right? Now that we have a service, this service will call the models that we created, and then the model interacts with the database. So tomorrow, if you make any changes to the database, the impact should be limited and will be limited to the models. But if there's no DB change, if you're making some change to the models, the only one that's impacted are these services, not the routes. And if you made any changes to the services, vice versa, only impact happens to the routes. And if your routes change, that's a slightly bigger problem. You want to make sure you're backwards compatible. So you'll make some other changes, but you'll also it'll have an impact on the services, but the models and other layers would remain untouched, right? So I understand there's a bunch of arrows going everywhere, but hopefully some of this makes sense. So we talked about services and routes. Now let's continue this, because I know we have more in this list. We have helpers, security, and tasks. At least those are the next three. Okay, so security, depending on how you implement security, we have several levels of security and encryption and whatnot, so we know we can be as safe and secure as possible. So I won't go into the specifics of how we have done it, but I'll tell you that anything that deals with security, you want to include in the securities directory. Typically there's also a filters file that filters your incoming requests. You may entertain certain IPs. You may want to have a whitelisted set of IPs in certain cases if you're talking to another server, if it's a server-to-server communication. But if it's coming from the client, you have other kinds of checks. So the security directory is going to have a bunch of files that deal with security, right? Creating the user session, destroying user sessions that are invalid, and a number of other things that are related to your application security, right? So I just leave it at that, because this is very, very specific to how your APIs are built, what their dependencies are, whether your API layer talks to another API layer, or how many other layers it talks to, and which of these are third-party APIs versus API other microservices you're running in-house. So the details of the security directory are very specific in that sense, but I think it should suffice to say that anything that falls within the realm of securing your app, securing your user, not user data, because your data lives elsewhere in a more secure, not more equally secure persistence layer, but you want to make sure that anything that you entertain does not go any further than this layer if you detect something that does not feel or sound or is correct, right? So this is where you do all of that stuff. So that's security. Now the next one is helpers. Now this is an API layer. We're talking about API app, API repo, what are we going to call it? So these helpers are all API related. Now if this happens to be in a UI repo, which I will talk about probably in a different video, these would be UI related helpers. So the term is just the same, but its purpose is completely different, right? And sometimes this is called utils. There are some differences, but you could sort of look at them, those names, use them synonymously or interchangeably. So helpers would be, let's say when you have a security layer, and we talked about routes and services and models, but at the end of the day, you're going to construct a response back to your client, right? So these are generally JSON responses these days. In the past, you dealt with XML. This can always change, but that's a preferred format is the JSON format, at least these days. Whether you're using Graph or REST, it doesn't matter. It's very likely that you're using a JSON response. So you want to construct these responses. So under helpers, you could have a directory called responses, and then in our case, we would have something called keys, blocks, pods, etc. Right? Tasks, notifications, and there's plenty of stuff that we do that goes here. Under this, we have specific files for each and every one of the responses, and in each of the response files, let's say I call it key response, whether it's .js or .rb or .java, whatever it is, right? So under each of these files, you're going to deal with the specific responses. For a given key, someone could fetch a key by ID, they could fetch a key by something else, and in some of those cases, the responses could change. If you're doing Graph, you would have resolvers and you would do this quite differently, but if it's REST, unfortunately, you're going to have handle these variations in your code. So depending on what you want to send to the user, if it's a mobile app, you end up sending much lesser the JSON file size, I mean not the file, the response size is going to be a whole lot smaller because you don't want to send too much to the app. If it's a web, you might send a little bit more depending on what UI JavaScript framework you're using on the web front end. But this is where the responses go. There's other things that go under helpers. Now, when you're implementing services, your services might need, let's say you have a convenience. I also mentioned helpers in util. You would have, let's say you're doing date formatting, right? I'm just going to call it date.sum extension. If you're doing date formatting, you have a date helper which deals with everything that's date related. So similarly, you could do other kinds you have a lot of other kinds of needs, and if you don't feel like it should go into services or routes or models or one of those other directories, helper or security, helpers isn't a bad place to store it. And then you'll realize that after you build more, you might find there might be a different location that's more suitable for it. But I generally go with helpers as a place to store stuff that I want to, but it doesn't fit into any of the other categories. Responses is just one example. If I go back and look at the code base, it'll jog my memory as to what other directories we have here. So that's helpers. And then we had one more in our list, and I called it tasks, which is pretty generic. But let's say if you're a backend Ruby server, Ruby app, if you're doing a lot of, let's say you're doing migrations, right? Not database migrations, because if you're using NoSQL, then you don't need to worry about database migrations. To a large extent, at least in the context of that term. But you would still need these rake scripts, whatever these scripts are, right? You might have shell scripts, rake scripts, all kinds of scripts under tasks, because you want to perform certain actions, whether they are backend services that happen in your production environments, or if you did them upfront before each of the deployments. Everything else that is kind of is related to your app, obviously, but it is not OLTP related, meaning it doesn't come into play in the functioning of a single web or native mobile request. You would do them under tasks. So in our case, we have a number of rake scripts, we have shell scripts, we have a bunch of other scripts that go in here, and I also have convenience scripts that I use for development purposes, which I store here. Now I could store them under test and create a scripts directory there. But again, there's no hard and fast rule here. Whatever works for you, and what works in one app may not work in the other app, right? There's always, even if you're building similar, I don't know what I mean by similar there. Really, it's like you're solving two different problems, but I'm just saying they're similar in terms of the fact that there's JSON responses, there's a security layer, there's third-party integration, and there are databases and whatnot. It's similar in that sense. The structure will still change. Now again, I'll talk about specific stack in maybe my subsequent videos, because when I build Node apps, one of the recent work I did was Node with GraphQL. That is actually quite, it's not super different, but it's just there are some fundamental differences in how these directory structures end up being created. Anyways, so I know it's a lot of stuff. I try not to say too many things in the videos, but never ends up being that way. But hopefully there's something you were able to take away from this. And let me go back to the first screen before I end the video, just to jog your memory. So we talked about config, lib, test, data, model, services, security, routes, helpers, tasks, and a lot more. So hopefully that was helpful. Talk to you soon. Bye-bye.